Yeah, good evening, everyone. So, joining hands. Chalo, cams on, everyone. Okay, we're not planning to start the class. We can just keep staring at each other. I don't have an issue. Staring competition. Who stares the longest on the screen? Okay, let's start it off. If I speak low, let me know. I'm down with fever. I'm feeling very bad. I think I got sick. Yesterday, we had a big revision with your seniors. 3.5 hours का formula revision था. And we finished only 11th का. अभी 12th का बाकी है. It went on till what? We had a doubt solving till night 1 o'clock. होता है. When the exam is in 1 week, na, people get doubts. So let's see. One more week anyway. After that, they'll become busy with boards. Let's see. Next one. Let's start with the question. So that we have a track like this. We have done this in vertical circular motion. Solid sphere, mass m, radius r. This track ka radius is capital R. There's no slipping here. So from the bottom of this thing, this height is h. So the first question is find h minimum to complete vertical circle. Remember this? We have done this in Bakpar energy. Others, you need to keep your cams on. Second one, this is a good one. So when this ball reaches this horizontal position, let this point A be the point on the circumference. Find acceleration of point A, where A is a point on the circumference. So this is the case when if h is equal to h minimum. Let's get this. So we have a solid sphere released from the topmost point here. Height h is from the bottom of this. So this sphere will come rolling. Remember, there's no slipping. So the question is find h to complete the vertical circle. If h is equal to h minimum, when this thing reaches the horizontal position, what is the acceleration of the point on the circumference? Is the question clear? Let's get this. I saw your major test portion, like rotation, will finish off properly, but let's see. Heat and thermo, maybe we can do a part of it if time permits. That is the reason if you see in the group, I posted a rotation sheet. It has only multiple choice questions because most of you have a problem with multiple choice questions. Single choice to still you do, but multiple choice you goof up. So best way to do that paper, right? How many questions are there? 60, I suppose. So you can take like 20 questions, take a 1 hour ka time, write it like a test. 1 hour, 1 hour, 1 hour. Write it like that. Don't solve it like an assignment. Write it like a test of, 1 hour. So 20, 20, 20 questions. Write it whenever you're convenient, and then resolve. That will be the faster way to learn. If you try to sit and solve like an assignment, you will chill out and solve. Uska kuch fayda nahi hoga. So when you try to sit and solve like an exam and you mess it up, and then you see the answer, you will understand better actually what happened. Get this thing. First, let's do the first question. The second one is a pretty good question. Right? This should be a proper advanced paragraph. Remember, you can't use root 5 GR. That was derived when there is no rotation. Try. You got a minute for the first one. I'll help you out a little. When you reach the highest point, is the velocity zero? No, no. If you don't reach up there with the minimum velocity, you will lose contact. So draw the FB at the highest point and find the velocity. Once you got the velocity, conserve energy between this state and this state. Isn't that what we did in vertical circular motion? So find the velocity when the ball reaches the highest point and then conserve energy. Yeah, 7 R by 2. See, step one. When the ball reaches the highest position, what are the forces? Normal reaction, your own weight. The center of mass is going in a circle. So there will be a centripetal acceleration, which is v square by r minus r. Isn't it? You should take the radius of the center of mass. And let this velocity be v here and the rotation be omega here. So for the normal reaction, n plus mg will be m into a centripetal, which is v square by r minus r. So mv square minus rg minus mg should be greater than equal to 0. So v should be root over r minus rg. So at the highest point when you reach, you need to have at least a speed of root over r minus rg. This is state 1, this is state 2. Energy in state 1 is equal to energy in state 2. We'll take the ground as a reference line for potential energy. Initial potential energy, mg h plus small r. Remember, you have to take the heights from the center of mass. Is equal to the final potential energy, mg 2r minus small r. So small r important. Because, see, now, this is the height you want, now. That will be 2r minus small r plus half mv square plus half I omega square. So solid sphere, so 2 by 5 m small r square omega square. This is the kinetic energy part. So this will be mgh. You send r that side. That will be 2 mg r minus r. Since it is not slipping here, v minus r omega will be v ground, which is 0. So v is equal to r omega. Never write v is equal to r omega directly. Meaning, I know it is ground, so I can write, but always be little careful about that. And this guy would be half mv square. Plus that will be 1 by 5 mv square. So 1 by 5. So 7 by 10 mv square. Take that v and substitute here. Mg goes off. You'll get h is equal to 27 by 10 r minus r. Check. 5r by 2 nahi aayega re, God. 5r by 2 will come when there is no rotation. If you think about it, some of the energy will go into rotation, right? So you need more than 5r by 2. इसीलिए देखो ना 2.7 r आ रहा है almost. If you remember in work per energy, it was 2.5 r. So we need more than that. Please have a look at this. You're getting the same question which you did in work per energy. With the rolling, it becomes a little different.
If
हाँ,
the
Arjun.
part after like the circular part of the track that was smooth, then we would have to conserve
Smooth,
energy at the bottom also, right?
smooth where the whole track is rough here. There's
But
no
then like
slip here.
if I'm saying if the circular part was smooth, then we would have to
हाँ
conserve energy at the bottom
हाँ,
also, right?
then you have to do bottom and then bottom to up. Then ये question हो जाएगा ना God? ऐसा हो जाएगा.
अच्छा हाँ, right.
Once you enter the smooth surface, omega change नहीं होगा. So that this will become this question. That is what you're saying.
Okay. Yeah.
Take it. Question is not over. The main one is this next one, B part. When you reach the horizontal position, what is acceleration? Once have a look at this. That is a pretty good one, which you actually have to learn. Any doubts on this page, please ask. This would be a first part. How mgh plus r? Think about it. When you say potential energy, where will you take? You take it from the center of mass to surface ground, na? देखो h मैंने क्या दिया initially? हाँ, Aryan, got it. छोटा r था.
So I can explain the step after the energy conservation.
What is there?
Is mgh plus r the step after that?
Potential energy plus kinetic energy.
Yes, after that. How did 7 by 10 mv?
That's a surprise. Think about it. Add करना गॉड यहाँ पे इतना सॉल्विंग तो करो ना v is equal to r omega. 2 कैंसिल होगा 1 plus half plus 1 by 5 ना.
And that 2 mg r minus r.
ये r इस तरफ शिफ्ट किया ना. देखो यहाँ पे r नहीं है. I skipped a lot of steps there. Check करो. What exam में you'll write each and every step क्या? At least solve तो करो ना खुद का. Why are you copying my steps? Copycat. Solving है रे कुछ नहीं है. Concept clear है ना? ये समझ में आ गया? Then ठीक है. Then you solve. You'll get it from there. I just substituted. I skipped a lot of steps. Meaning I shifted this r this side तो क्या हो गया? 2r होगा ना? I took out 2 common. Sure. Still confused? Please ask. Calculations, I have a habit of skipping few steps. So exam में तो I'll write even less steps actually. For you to understand, I'm writing more. Next one. Karo. Got a minute, another 2 minutes. Find the acceleration point. Where A is the point on the circumference of the sphere. And when the sphere has reached horizontal position. I could have made it more deadly by giving somewhere here, but ठीक है. Meaning you got this, so you can do any other variation also. Try, think about it. Take 2 minutes. Get me the main framework. It's okay if you don't get the exact results as such. Anyone confused with any particular step, please ask. Solving part you're confused, you can ask, don't hesitate. But then when it comes to solving, I will say something or else you won't solve. Concept is clear, I suppose, na? Energy conservation. The solving part, you can figure it out. You know how many accelerations are there at point A? 4. So Chabi. Think I'll give you a minute. Let me go. Let's go step by step. I'll help you out. Forget about point A. When the sphere is here, can you write the FBDs and find the acceleration of center of mass? Do that. Draw the FBD and find the acceleration of center of mass. Let's go step by step. How many forces are there? Mg, normal reaction, friction. Not slipping now. Then what are the accelerations? Acceleration of center of mass and alpha. So if you take torque about this point here, that would be mg into r is equal to I about, let me call this point as b. I over b into alpha. So that will be mgr is equal to 7 by 5 mr square. There is skipped a step. 2 by 5 mr square plus mr square. Parallax theorem. Then from here we get alpha is 5g by 7r and a center of mass is 5g by 7. This is alpha, angular acceleration, and a center of mass. Clear? Now, when the ball is released from here, this is state 1, this is state 2. Let this velocities be okay. Let this velocity be v and rotation would be omega. Basically, it is decelerating now. That's why alpha is opposite to omega and a is opposite to velocity. Energy in state 1 is equal to energy in state 2. I'm choosing the ground as reference. Potential energy mgh plus r is equal to potential energy is mgr because ये height चाहिए ना. This is r only. Smaller r नहीं आएगा. That would be half mv square plus half I omega square. That is 2 by 5 m r square omega square. And since it is not slipping, v is equal to r omega. If you solve this, यहाँ से v भी आ जाएगा, omega भी आ जाएगा. H का value तो we know from here. We can substitute that. ठीक है, that is fine. There. Now I know a, I know alpha, I know v, I know omega. Now what? I kept all the ingredients ready. Now, how do you combine all this to get the acceleration of that point? Think. I'll give you a minute. Why not mgr minus r? Where is the center of mass? Where is the reference? Calculate, no, height god. There is a center of mass. So from the center of mass to the ground, what is the height? Aryan, did you get that? Then why will you take r minus r now? Let's try. Why do we need V and omega? Ouch. See, first of all, if you just look at the center of mass here, the center of mass itself is going in a circle. Agreed? So it will have a centripetal acceleration, which is v square by r minus r. This is your a centripetal. And this is a center of mass, which is the tangential acceleration. So acceleration of center of mass with respect to ground will be minus v square by r minus r I cap minus a center of mass, which is 5g by 7 j cap. Perfect. Now you are asking about a here, this point a here. So if you stand on the center of mass will think you are going in a circle, isn't it? So center of mass ka frame mein you'll have centripetal acceleration, which is omega square smaller. You are going in a circle with respect to center of mass. So center of mass ko lagega there is a centripetal acceleration towards the center, and this would be a tangential, which is a tangential this way, which is smaller alpha. So acceleration of a with respect to center of mass. So center of mass itself will think a is going in a circle. So that would be omega square small r I cap minus r alpha j cap. So therefore acceleration of a with respect to ground will be acceleration of a with respect to center of mass plus acceleration of center of mass itself is going in a circle, a center of mass into g. So if you add this guy, so you'll get omega square small r minus v square by r minus r I cap minus r alpha plus 5g by 7 j cap. There are total 4 parts there. Basically, I know why you thought 3, because we thought 3 because देखा ये translation था और ये rotation था ना, but here this is rotation plus rotation ना. Center of mass itself is going in a circle and this A is going in one more circle. So rotation plus rotation, so you got tangential plus centripetal, दोनों आ गया, 2 times you got. That's why you got total 4 parts. Is this making sense, everyone?
Yes.
Got it. So first, anytime ना, remember this thing, anytime they ask you acceleration of any point on the body, पहले center of mass का निकालो, then go and stand on the center of mass and then see the acceleration of that particle with respect to center of mass and add them. Is that clear, everyone? Now, for example, if this whole setup was placed in a box and if this was accelerating with a dash, so center of mass का एक और component आएगा a dash. You can just keep adding more. Check it out. It's a good one. Literally everything you got in this, if you see. NLM, friction, circular motion, work power, energy, collisions बच गया. And yeah, rotation तो है ही. Have a look at this. That's why I said this is a proper advanced question. तो वो क्या था फिर 5G/7 is what? Acceleration of center of mass ना? Tangential downward.
फिर वो अपने विद रिस्पेक्ट टू ग्राउंड वाला वो क्यों नहीं?
Okay. बेसिकली यहाँ पे सेंटर ऑफ मास का दो एक्सेलरेशन है, तो उसको कोई दूसरा वर्ड यूज करते हैं. देन लेट्स से A dash. ठीक है.
These two are both different. This one
A
is
center of mass will be this. There are two parts ना, tangential plus centripetal. This is only tangential part, isn't it?
अच्छा.
देखो ना, पूरा स्पीयर छोड़ दो, ये पार्टिकल सर्कल में जा रहा है, तो देयर इज एन A tangential, देयर इज A centripetal ना. So center of mass का A tangential, let's call it A dash. I think that would be right. It might give confusion actually. तो इसको shit. This is A dash. So basically that's the tangential acceleration of center of mass. This is the centripetal acceleration of center of mass. ठीक है. The resultant is the acceleration of center of mass. ठीक है. Check. Next one. Next one. Any doubts? Anyone not clear with any particular step?
So after that, can you explain again what did you say about standing on the center of mass?
तो पहले center of mass का acceleration निकालो. Then stand on the center of mass and look at A. तो A का acceleration with respect to center of mass आएगा. Then add them.
Okay.
Two parts, right? First find the acceleration of center of mass, and with respect to center of mass find the acceleration of A, and then when you add them you get acceleration of A with respect to ground.
Okay.
ठीक है. Next one. Any doubts on this? It's a good one. If you had taken a point somewhere here, then क्या फर्क पड़ेगा? Then ये angles में आ जाएगा ना, R alpha and omega square R. Then you have to divide I cap J cap. That would become more complex. So I kept it at A so that I don't want it to add it up. The same question, you could have asked like this also. We have a cylinder, sphere, on top of it another sphere is going. Getting it? Idea same thing. There also center of mass is going in a circle. With respect to center of mass, this point is going in a circle. So it's a rotation plus rotation. They look similar actually. Next one. We have a rod like this. This is hinged here. Mass M, length L, mass M, length L, 90-degree rod, released from rest. So if I call this thing now O, A, B. So when you leave this, because of gravity, the rod will become like this. Basically, it became vertical. Find omega and hinge reaction when the rod becomes vertical. Omega is fine. Hinge reaction is a little messy. Just get the equations. More than actual result, I want you to see how will you draw the FBD and everything. When OA becomes vertical. Find omega first. So this is your initial state, final state. To find omega, right? You can do this thing actually. So this center of mass will be here. This center of mass will be here. So one will come here, meaning one has traveled from here to here. And two has traveled from here to here. That means this guy has traveled L by 2. This guy also has traveled L by 2. So I can directly write loss in potential energy is equal to gain in kinetic energy. So that would be mg L by 2. So you can take each rod separately. Could have taken center of mass, but potential energy will get easily with we take separately. Now you'll take half I about hinge into omega square. Now I about a hinge कैसा निकालेंगे? So this is one rod plus this is the second rod. You want moment of inertia about this axis. So this guy would be ml square by 3. And remember, we have to use parallaxes theorem. So this is L. This is L by 2. So this is root 5L by 2. So this will be ml square by 12 plus md square. If you add this, multiply 3, that will be 16. So 4 by 3 ml square. So total I about the hinge will be 5 ml square by 3. Omega will be root over 6g by 5L. Check. This is the easy part. Now find the hinge reaction. Please check the steps what I did. You can do this also. You can find the center mass of these two, and then you can see the change in height of that, but it's the same thing. End of the day, you want change in potential energy, so just take the change in potential energy of each rod. So this is the delta PE of rod OA, and this is delta PE of rod OB. Please check. Just get me the FBD for the hinge reaction, and you can just write the equations and leave it. Don't solve. How do you find the hinge reaction? Just to give an idea, system का center mass लेना पड़ेगा. Doing individually will be big mess up now. Try. You got a minute. Let's see the FBD. This concept is not really that great, but the calculations are messed up. And because of that, it looks pretty good. So if you look at the forces here, let's find the center of mass first. So that guy will be somewhere here. I hope you remember we have calculated this before. This is L by 4. This is 3L by 4. Remember where we did this? Center of mass में कहीं पे किया था equilibrium problem में, if you remember. Rotation equilibrium में we did this thing there. So center of mass was that 3L by 4 and L by 4. Okay. Now let this be smaller. So O to C is smaller. Perfect. Someone, what are the equations? Let's see. You messed up one part, right, Aryan, there. So when you draw the FBD, whenever there is a hinge, Ny, Nx, center of mass, weight is 2 mg. So take the total mass, isn't it? So it is 2 mg. These are the forces. Next thing, this whole setup is rotating with alpha. And on top of it, from the center here, there is one more force here, centrifugal force, which is 2m omega square r. This is the centrifugal force on center of mass. If you're going in a circle, there will be a centrifugal force. That is one more force you have to include. And the whole thing is rotating with alpha. So if you take the relation between them again, between alpha and a center of mass, that is another headache. So this center of mass is actually going in a circle like this, a center of mass which is smaller alpha. And this angle theta, where tan theta is 1 by 3. So we have to divide this into components. This is theta, so this is theta. So this would be AX and this would be AY. So AY will be R alpha sine theta. AX will be R alpha cos theta. There, now you got everything. Now, if you write the vertical direction of forces, remember this is also theta here. You have Ny minus 2mg minus 2m omega square r cos theta is equal to 2m into acceleration of Ay. Nx plus 2m omega square r sin theta, centrifugal force का component भी लेना पड़ेगा, which is 2m into Ax. Torque about hinge, luckily this is 2mg L by 4, because centrifugal force का torque नहीं आएगा, it is passing through that, is equal to I about hinge into alpha. There. Here the biggest catch is this is the headache. Centrifugal force भी लेना पड़ेगा. ये acceleration center of mass also is going at some weird angle. It is lengthy. So more than solving, I want you guys to get this part right. Meaning, if you understood this, they can ask part of the questions. Getting the FBD, the accelerations, and the relation between acceleration, that is more important. Solving part is fine. Have a look at this. Anyone not clear with any particular part, please ask. And remember, total mass will be 2m now. अभी यहाँ पे problem with that each part, problem क्या होगा? If you take इसका center mass, इसको center mass separately, this will go like this, this will go like this. You have to take उसका components. It is pretty messed up. हाँ, Aryan, clear ना? Arjun, got this? Anyone not clear with any particular step? Why did I write any particular force? What is that? Anything? A center of mass can be same as हाँ यहाँ पे तो tangentially होगा ना. It is a hinge. It's pure rotation.
So can you show the previous slide for 1 second?
So you need omega for this question. If you don't know omega, you can't get the centrifugal force.
Okay.
A
Thank you.
simpler version of this question, simpler version would be like this. Just take one rod, and when the rod is rotated by theta, find hinge reaction. So then forces क्या होगा? Ny, Nx, acceleration of center of mass, centripetal acceleration of center of mass, and mg. That would be little easy. Omega लगेगा anyway. Because it became an L-shaped rod, the shape became little messed up. A simpler version would be a single rod. Clear with this? Any doubts on this? Next one. Maulika, clear with this? Neil? Anusha? Got this? Utsa, clear, na? Vartika? Vidyut? Clear. Next one. We have a solid sphere. Mass m, radius r. Going with v and rotating with omega. Find kinetic energy of upper hemisphere. I don't want full. And find force between upper and lower hemisphere. Let me ask you, force between left and right hemisphere. अच्छा ये कौन है? Up and down is fine. Up and down is also same only. It won't be half of the total, huh? Why it won't be half? Upper points का speed will be v plus r omega. नीचे का points will be v minus r omega. So lower points are traveling slower, na? So the lower hemisphere will have less kinetic energy compared to the upper hemisphere. So it won't be half of the total. So upper hemisphere should have more than lower hemisphere. इतना तो idea है. How will you calculate that? Question is clear? Get this. You have a solid sphere rolling on the floor. Find the kinetic energy of the upper hemisphere and the lower force between left and the right hemisphere. The easy to write, but the values are messed up. Again, this is more of a calculation issue. See, just take the upper hemisphere. So the upper hemisphere, where is the center of mass? 3r by 8, na? If you don't know the result, that will how it will happen. हाफ डिस्क का सेंटर मास कहाँ पे है? हाफ डिस्क एनीवन?
2r/pi.
है 2r/pi हाफ रिंग था.
by 2.
3r/4.
Half disk 3r/4 it doesn't exist only.
4 pi था ना?
Yes, 4r/3 pi cuts.
Oh अच्छा okay.
Half disk. हाँ राइट आर्यन, डोंट फॉरगेट. तो इसका वेलोसिटी क्या होगा? VCOM प्लस 3r⍵/8 ना. So kinetic energy of upper hemisphere will be half. Remember mass became half m/2 VCOM square. So let me write that thing. Half mVCOM square plus half ICOM omega square. Mass became m/2, and this is VCOM plus 3r⍵/8 का square plus half. अभी देखो ICOM क्या होगा? That is a trap. This is the center ना. This I know. This is how much? 2/5 mr square का half. But center mass is here, isn't it? Center is not the center of mass. So IO will be I center of mass plus mass became m/2 3r/8 whole square. So यहाँ से have to find I center of mass, which is mr square by 5 minus 9 mr square by 128. Numbers are bad. Now take that and substitute here. Half ICOM omega square. Calculations are bad, but got the steps. So when you take the upper hemisphere, the center of mass is not in the center anymore. So उसका velocity will be v plus 3r⍵/8. And you have to take moment of inertia about the center of mass, and center of the hemisphere is not the center of mass. So we have to use, and about center though I know na. About center though you know. Sure with this? And what about the forces? You have to draw an FBD. So if you draw FBD of one hemisphere, the forces will be center mass will be somewhere here. So this will be mg/2. Because you're going in a circle, there will be a centrifugal force. m/2 omega square 3r/8. Because this thing is going in a circle. So this force will be somewhere here. So the force due to the other disk, F is the force due to left on right hemisphere. So actually both are pulling each other. They're not pushing each other. This would be 3m omega square r/16. Ground में तो n होगा ही, so that will balance the vertical forces. And yeah, friction we don't take because there is no external, so friction will be 0. Yeah, F is 0 since there is no external force. And it is not slipping, so friction need not come. If there is an external force, वो भी include करना पड़ेगा. Check it out. So this is the force on the left half, on the right half. If you take upper half, क्या difference पड़ेगा? If you take upper half, mg 2/2 will also come. Centrifugal force will come this way, and normal reaction will come this way. Then it will be centrifugal force minus mg/2. Got it? That would be the up and down ka this thing. And here, na, if I ask you energy of the left and the right hemisphere, that is easy, isn't it? They will be equal. Energy of left and right will be equal because the velocities are symmetrical. See, the speeds will be same of the left hemisphere and the right hemisphere. So if they ask you energy of left and right hemisphere, it will be half of total. Up and down will not be half of total. Please check. Clear with this, everyone? Any doubts on this? Please ask me. Clear? Next one. We have a disk which is rolling on a floor with omega naught is constant. This is the disk, mass m, radius r. Disk is rolling in a circular path on a rough horizontal ground. On a horizontal surface without slipping. Meaning after some time, na ring will come here. Are you able to visualize how is the ring rotating? Ring will be here. Ring will be here. ऐसा ऐसा जा रहा है circle. It is rotating and going. Able to visualize? So the disk is straight and it is rotating and going in a circle. This length of the rod is L, the massless rod. So this is connected by the rod to the center. Disk ka mass m and radius r. So there is no slipping on the ground. This is a pretty good one, right? Find omega of the disk. Find kinetic energy of the disk. Find angular acceleration of the disk. This would be a very good one. Alpha of the disk. Let's get this. Is the diagram clear? So on a ground, the disk is vertical. It is going in a circle. Anyone confused the diagram, please ask. There are three parts. Let's get omega of the disk first. I'll give you a minute or two for that. Anyone not clear with the diagram, please ask. Just give it a try. I'll be back in a minute. Adrit. That is, yeah, that's part of the answer. Ouch. Disco यहाँ पे 2 ओमेगा से. Look at the first part. Since it is not slipping, this guy is the velocity of center of mass, and this is rotating with omega. Let's call it omega. So this is your rotation omega. So at the bottommost point, you have a velocity v and the velocity r omega. Since it is not slipping, v minus r omega is equal to v ground. But v is nothing but L omega naught. So therefore, omega dash, it's looking weird. So omega dash will be omega naught L by R. Basically, this is the self-rotation. Rotation is omega dash, revolution is omega naught. So omega of the disk, this is the catch here. There are two components here. One is omega naught, which is upward. This is constant. Plus omega dash, this guy, direction is not constant. This direction is continuously changing. This is a variable component. So what is alpha? Alpha of the disk is rate of change of omega. So here omega is changing, na? Magnitude change nahi ho raha, but direction change ho raha hai. That means there is an angular acceleration for the disk. So if you want magnitude, iska square karke add kar lena. So if you want omega of the disk ka magnitude, that would be root over omega naught square plus omega dash square. So the disk has actually two angular velocities. There are two axes of rotation. Remember in the beginning I told you, degrees of freedom, you can have rotation in different planes. So till now we always solved only problems with one axis. So kabhi problem nahi hua tha. But if you're rotating with multiple axes, you have to take different omegas. Alpha of the disk will be d omega disk by dt. So in this, the omega naught is constant. That will be d omega dash by dt. So omega naught is constant, so its differential will be 0. How to find that omega dash is the catch. Kinetic energy. Again, you're missing this point. There are two parts. Remember, there is a translation and rotation. Rotation, there is a rotation and revolution. I hope this part is clear. Have a look at this. Try, I'll give you a minute more. Let's try to find alpha. Energy, abhi aa jayega. Energy is actually easy. If you remember, isn't this question energy? Yahi hai na question wo. The energy is same as this question. The swinging table fan wala. So kinetic energy will be half mr square by 2 omega dash square plus half mr square by 4 plus ml square omega naught square. This is the rotation ka kinetic energy. This is revolution ka kinetic energy. You want detailed working, you can refer question 43. Usme hai. It was the same thing. In that question 43, there's a rod also. Here, there's rod is massless, so we ignore the rod ka moment of inertia. How to find alpha? Try. I'll give you a minute from there. Please ask anything you're not clear. The omega dash part, energy part, anything. Now listen to this thing. This thing, na, ye thoda different hai. So omega dash is constant, but I know the direction is changing. So this is what we do, everyone. If you see the top view, if I choose this as x-axis and choose this as y-axis, let this, the disk, right, come like this. So omega dash is like this. So matlab disk has become like this. And let this rotate by theta. Okay. So here, what is theta again? So d theta by dt is omega naught. So this theta is changing because of omega naught. समझ में आ रहा है कैसे? That rod is rotating because of omega naught. So if you take components now here, this is theta. This would be omega dash cos theta and omega dash sin theta. So what is changing is direction, na? So omega dash bar, omega dash will be omega naught L by R cos theta I cap plus sin theta j cap. You have to differentiate this quantity. So d omega dash by dt, magnitude constant tha, omega naught L by R, that will become minus sin theta d theta by dt I cap plus cos theta d theta by dt j cap. So d theta by dt is nothing but omega naught. So this will become omega naught square L by R minus sin theta I cap plus cos theta j cap. And if you observe this, you know, how is this acceleration alpha actually? So when the disk is going in the circle, this is omega dash, this was omega naught, alpha is like this. Observe and see, if I do dot product of this and this dot product, dono zero aayega. Basically, the vector has become perpendicular to the omega dash. You can check from dot product. This is perpendicular to both omega dash and omega naught. You can check from dot product. So alpha का value का magnitude is omega naught square L by R. इसका भी magnitude constant है, and the direction is tangential. It is along the circle. Alpha is like this. You're getting how it is? Omega is going in a circle. Alpha is going in tangentially. We will do one more question like this later on in angular momentum. It's a pretty good one. Have a look at this, how we did. So this is how, you know, magnitude is constant, but direction kaisa aayega, right, in terms of theta, I cap, j cap, and then differentiate. So this is a technique you should know. Whenever you have something constant but it is rotating, you write an I cap, j cap, and then differentiate. And that, हाँ उत्साह बोलो ना.
सर वो अल्फा टेंजेंशियल कैसे आया again बता.
देखो ना, if I do dot product with this, zero आ रहा है. Means it is perpendicular to omega dash, and omega naught is k cap. तो इसका dot product भी zero आ रहा है. Means it is perpendicular to both the vectors. मतलब it should be like this ना. It should be into the plane, isn't it? X Y Z जैसा दिख रहा है, isn't it? Sure. So alpha will be going along the circle. This is pretty interesting one, because you know what happens, सबका वही logic है. Sir, omega naught constant तो alpha का क्यों आएगा? यहाँ पे alpha आ रहा है not because of omega naught का magnitude, because of the direction is changing. These questions idea doesn't come because, you know, till now in circular motion everywhere, right, we always studied about single axis. So we never had problems like this. ऐसा issues नहीं आया था. You know, because there's a double axis rotation, these things are messed up like this. Definition is still same. Alpha is d omega by dt, but that omega is in multiple directions. Please check. Anyone not clear with this, not convinced with any particular step? Again, whatever we did today, if you observe, all problems are pretty good. Advanced ka paragraph questions. Everything, please try it again on your own. These are the kind of questions which will teach you concepts. अभी सोचो ना, how will I teach you this as a concept? कितना books भी पढ़ो, ये concept नहीं आएगा. You have to solve problems. You will get stuck in this kind of things, and then you will learn, okay, इसको ऐसा करना है. So more than saying this is a concept, right? This is a technique of solving a particular model. These kind of things you can't learn by reading books or by reading notes 10 times. You have to solve questions. Clear? Next one. Any doubts on this? So the whole thing was a pretty good one. Especially alpha is the best. Energy though was like 43 problem only. Let's see one more. One more. Theta. H mu m r solid sphere.
Sir,
Oh God.
in the previous question, can explain how you get that omega vector? Omega
I
dash
cap
vector.
J cap. Omega dash का horizontal vertical component I cap J cap.
But omega
Resolution रे. हाँ
vector should be this side, right?
this side मतलब ये top view है रे God.
From top view, it is rotating.
In a circle. ऐसा
Clockwise.
जा रहा है ना ओमेगा डैश देखो ना ऐसा जा रहा है ना. ठीक
So
है, यू आर सेइंग इट रोटेटिंग दिस वे बोल रहे वो छोड़ देना, वो ठीक है ना. और मैक्सिमम सिर्फ आई कैप जे कैप में रिवर्स आएगा बस. पर लॉजिक समझ में आया ना कैसा जा रहा है. आई एज्यूम्ड इट इज गोइंग दिस वे. ठीक है. इफ यू एज्यूम दैट वे देन कुछ डिफरेंस नहीं आएगा. देन यू विल राइट लाइक दिस इज व्हाट यू आर सेइंग. आदित ये बोल रहे हो.
where
दिस इज व्हाट यू आर सेइंग. यू विल राइट लाइक दिस.
now that omega dash vector should be inside.
इनसाइड बोल रहे हो. ऐसा. यू आर राइट. ठीक है ना, लेट इट बी. मतलब let's assume it is rotating that way. What he's saying is right. Omega dash actually अंदर होना चाहिए from that way the diagram is given. अब पूरा change करना पड़ेगा. So we'll do one thing. ये सब change हो जाएगा रे. ठीक है, छोड़ देना. You understood ना? You got the concept. Let it be. I know that was omega dash should have been inside, but ठीक है. Next one. Mu is there. First one. This is this we did before. Find a mu minimum for no slipping. That is fine. Now, if mu is half of mu minimum, now it will slip. Find v omega time taken when it reaches ground. Work done by frictional force. If I said total work done by friction. Work done by torque due to friction. दोनों सेम नहीं है. In this especially, na, this is the best one. The work done by torque due to friction. Let's get this. First was easy. First and second are fine. Get it. You got a minute. Tan theta 2/5 क्या 2/7 आएगा ना अभिनव. Friction mg sin theta. This is acceleration. This is alpha. Initially, it is not slipping, na? So I can take torque about the bottommost point. Now be careful. If it is slipping, you can't take torque about the bottommost point. That will become a non-inertial frame. So torque about A will be mg sin theta into r is equal to 7/5. Maybe you forgot to subtract that thing, I guess. Mg sin theta minus f is ma. If you substitute A here, f will be 2/7 mg sin theta. This should be less than equal to mu mg cos theta. This should be greater than equal to 2/7 tan theta. Check. Now in the second part, you're saying this friction is half of this. So mu is 1/7 tan theta. So now it is going to slip. This is actually easy. This also I taught you how to do. So if it is slipping, mg sin theta, this friction is F max. Now, this is insufficient friction, it slips. This will be A and alpha. This will be mg sin theta minus this will be mg sin theta minus mu mg cos theta will be 1/7 mg sin theta. A will be 6/7 g sin theta. अभी क्या करना है यहाँ से? Find alpha and find time taken to reach the ground. Find omega, I mean to say. Tan theta वो cos theta आएगा ना निका. Mu mg cos theta ना वो tan में sin cos cancel करके sin बच जाएगा. That's how you find A. How do you find omega and time taken? Time taken is easy. H by sin theta is equal to half AT square. तो टाइम आ जाएगा. Find omega. Find time taken to reach the ground हो गया. Find total work done by friction. Find work done by torque due to friction. Fine, I'll give another 2 minutes. How do you do that? Any doubts on this page, please ask. That a mu minimum is a standard question. You should know proper mains level question. Find a mu minimum. How do you get omega? पहले तो you have to find alpha. torque about center of mass will be F max into R is equal to ICOM into alpha. The F max will be 1 by 7 mg sine theta R is 2 by 5. I'm asking, don't use A is equal to R alpha. It is, A is not equal to R alpha here. It is slipping. So alpha will be 5 by 14 g sine theta by R. Oh yeah, then omega final will be omega initial plus alpha t. So omega final will be alpha into time, and time will come from here. Time you have to get from translation. Check the steps. Any doubts on this? No, Aditya, clear with this? Anika, clear na? Abhinav?
Yes, okay.
Ali? For this? Palaksh? Clear? Neil? Udian? Question अभी तक हुआ नहीं boss. Actual question बाकी है. Find work done by friction, total work done by friction, and work done by torque due to friction. The torque भी work करता है, so that is a little different from friction का work. So how do you write that? You get something interesting here. Think, take a minute. Work done by total friction till it comes down. Work done by friction on the body, right? Which case matlab, okay, case बोल रहे हो, for case B. Case A would be easy, right? No slipping, na? Total work is 0. Ouch. Think. I'll give you a minute. It is pretty easy. Matlab, you should think for a minute. I'll show you. It's easy. The headache is calculating. Ye sab headache tha actually. That part is easy. Work done. GH by 7. Itna अच्छा answer I don't know actually. See, what is work done by all forces here? The work done by external forces will be what? Change in potential energy plus change in kinetic energy, na? So here, what is external force? Ento is not doing work. Mg is not an external force. So work done by friction, that would be change in potential energy. Finally is 0. Initially mg h plus kinetic energy. Initially 0. Finally half mv square plus half I com omega square. You know V, you know omega. This is work done by friction. What is work done by torque? Do you remember the statement? What is work done by all forces? Change in translation kinetic energy. So change in kinetic energy. So here work done by all torques will be change in rotational kinetic energy. If you think about it, what is torque doing? Torque is increasing omega. So this would be half I com omega square. This is the work done by torque due to friction, which is positive. Total work is negative, but torque ka work is positive. So you need to understand here what is torque actually doing. What do you know what torque is doing? Torque is stealing energy from translation and giving it to rotation. You're getting it? If you see the friction is opposite, so it is stealing energy from mg sine theta, and some of the energy it is giving to rotation, remaining is becoming heat. In case of pure rotation, when there is no slipping, whatever energy it steals from translation, it gives everything to rotation. So this is a pretty good one. It is positive. The work done by torque due to friction is positive, but work done by friction is negative. because it is actually dissipating energy. It is like you're taking 100 from me and you're giving only 50 rupees to your friend. 50 rupees you stole it or you ate it. Work done by friction is negative, but work done by torque due to friction is positive. They can ask you this as theoretical questions. Have a look at this. So we can actually write the general formulas also like this. So we can write work and power due to torque. So if you remember the formula, small work done will be F bar dot dr bar. So this can be written as F is equal to F tangential, and this will become R d theta. So basically, if something is going on a track here, so this is your R d theta. This is ds. And this is your tangential force. And we know F tangential into R becomes torque. So there, so work done ka formula can be written as integral torque dot d theta. Remember, torque and d theta also are vectors. If torque is constant, then you can write torque d theta. Similarly, power will be rate of change of work done. So in this case, it will be torque dot d theta by dt. You can see the resemblance. It is torque dot omega bar. Just like F bar dot V bar, you have torque dot omega bar. Work done is F dot ds. It is torque here dot d theta. So this is how also you can find work. So idea is the same. Have a look at this. Check it out. Take a break. Come back by 7:30. We'll have a small break. Any doubt so far? Anything that you didn't understand, please ask. Anything that you're not clear, any particular step. We did quite weird ones today. Take a break and come back. Anyone has any doubt, you can ask, or else come back by 7:30. No doubts? Chalo, I'll be back in 5 minutes. Yeah. Really tired. Huh? So let's start. I had a feeling morning it felt like today winter started. Last time I felt there was a winter today. Let's see. And I think I fell sick. There, this is all one part of the story there. The next thing. Chalo, cams on everyone. Clear, no, Anusha? Go ahead.
Yes, sir.
Okay. Instantaneous axis of rotation. IAR. Now you can have different symbols, IAS, OR, everything, but here. So what is this IAR? So IAR is an axis about which body can be assumed to be in pure rotation. For an instant. So if the body is rolling or doing whatever it is, for an instant you can think it is in pure rotation. So IAR, right, is actually pretty useful to find velocities. Kinetic energy and angular momentum. If someone asks you find the kinetic energy system, instead of finding translation, rotation, all that, just stand on the IAR and write half I omega square, you'll get the answer. So it would be like kinetic energy of the system would be half moment of inertia about the IAR into omega square. You'll see this thing, IR is pretty useful. There are certain cases, right, which are very difficult to solve normally. This will help a lot. So, and one thing you have to be careful, it is not preferable to take, for torque. Because IR is not at rest, it can be a non-inertial frame. Since it can be a non-inertial frame. So whenever you talk about IR, don't take torque about that, but you can find energy, velocity, all that stuff about that. Comes on everyone. So let me give an example how this works. Turn in the page. So if you have a disk going with V and omega, let's say it is not slipping. Now, do you remember in the beginning we said if you take this point as A, if you take any point P, if you ask A, what is B doing, what will it say? So A will think B is going in a circle. So if you look at here, observer at A thinks every point is going in a circle. So if you take velocity of B with respect to ground is velocity of B with respect to A plus velocity of A with respect to ground. But since it is not slipping, this term is 0. So doesn't that mean velocity of any point with respect to A is the velocity of any point with respect to ground, isn't it? Isn't it? So that means when you stand on A and look at any one, what you are getting is actual velocities now. Is that making sense? So here you can clearly see here. So it is not slipping. So it behaves. So the point A behaves like a hinge. And the whole body seems to rotate about it for this instant. This is happening because the velocity became 0. So here A is IAR. Now you need to understand the point A is not constant. So initially A is IAR. After that point, A must have gone here. So this is your IAR. After some time, A must have gone here. This will be IAR. So IAR is basically the point on the ground. It is not point A. This is the reason we said you can't take torque, but that point is actually accelerating. The point on the ground is IAR. It is not A. That so A can move. So different points become IAR at different times. Points in contact with it become IAR. So IAR is not a fixed point. Have a look at this. Have a look at this. So the idea here is if velocity of any point as seen by A is the actual velocity in the ground frame, then the system is as good as if you put a hinge and if you rotate the whole thing with omega. Mathematically, it is the same thing. Max won't understand whether it is rotating, rolling. Max will simply say it looks like it's a hinge. Please have a look at this page. Clear? Now see how is this useful. So if you take this as IR here, if you take this point as A, if I take this point as B, if you remember beginning May when I taught you velocity profile, this is how I taught you velocity V, omega. We can split this into V, V, V translation plus everything is rotating with R omega or omega. So this was point A. This was point B. So this is how we did. So we wrote velocity of A is V plus R omega, which was 2R omega because V is equal to R omega here, no slipping. Whereas velocity of B would be Vi cap minus R omega J cap. Now using this condition here, this is a very important technique. We are going to use this again, in 12th May, we have a chapter called electromagnetic induction. Helps a lot. So this is what we say. Treat it like a hinge. This is the race 2R. It is going in a circle. So what is the speed? 2R omega. So again, एक step में. No need to do translation, rotation, कुछ भी नहीं. Directly R into omega. You want velocity at B. This distance is R root 2. So the velocity will be this way, which is R omega root 2. Isn't it? So any point on the disk, you just take the distance and finish it off. If you want some point here, let's say distance smaller, the velocity will be R omega. You can treat that as a hinge and assume whole disk is rotating with omega. So just find the distance and into omega, you get the answers. So mod VB, if you see, this is actually R omega root 2. That's how you can find velocity of any point on the disk without the translation, rotation, vector, all कुछ करने का जरूरत नहीं है. Have a look at this. Let me show you a question on this. So there, the IR is quite useful to find velocities and energies. We will see. Any doubts on this page? Let's see a question. Abhinav, Arjun, clear with this?
Yes, sir.
Aryan, Palaksh? Clear, no? Yasha, clear? Udayan, got this? Let's see a question. So we have a disk. So for the disk, we know IR is the bottommost point. I will teach you how to find for any other random system also. This is a good question. V, omega, no slipping. It's a disk, mass and radius r. This is point A. This is point B. This is point C, and this is angle 60 degrees. Find speed of point C. Find the number of points on the disk with speed V. Velocity of the center of mass is V. Second is a good question. Proper mains level question. Find number of points on disk with speed V. Find radius of curvature of A and B. Hope you remember radius of curvature in circular motion. Chalo, let's get them. Anyone didn't understand the question, please ask me. Nanika, where are you? Nanika is missing. Keep trying, just give it a try. A part V plus R omega. Nere, Aryan. Give me answer in terms of V for the first part. I'm asking speed of C. V will be equal to R omega, na? Because it is not slipping. मैं C का velocity पूछ रहा हूँ. Adrit, you got it right. Others, do type your answers. I hope everyone has seen this week ka test. It is a 60 questions ka test. 2 hours. It has full kinematics, NLM, friction, circular, work per energy, center of mass, momentum, collisions. So do give it a try. It's a good paper. Next week, you have a major test coming up. That will be a good practice. And I gave an option for retest also. So if you want, you can write the test again. Questions are good. So do give it a try. Right, Utsa? Aditya got it. Nee, Adrit, that is wrong. Ali, that is wrong. And I also kept a paper on rotation and ray optics also online. So that is there till month end. You can write. I'll tell you again, the best way to revise for major test for physics, revise the notes, write papers. That's it. You won't be able to go and solve multiple things now. You won't have that kind of time to do everything. Best thing would be to write papers, write 3-4 papers and just resolve them. Until now, whatever papers you have written, you can take them out and you can resolve them and get your doubts cleared. I know 100% complete nahi hoga, but you'll cover at least 80-85% in a very short time. Don't try to go for perfection. That will take a lot of time. If you can complete 80% in 5 hours and 100% takes 15 hours, it is not worth doing that extra 20%. Instead of that, you can use that time to study maths and chem. End of the day, total score important. Once you reach all the scores are coming stabilized, 70, 75 you're crossing in every subject, then there's different story. क्या करना था? C is easy, gods. So this is your IAR. So I just need to find this distance here. So from center, you said this is 60. So if you drop a perpendicular, this also will be 60 and this also will be 60. Total 120, na? And this distance is R. So this will be R sine 60 and that will be R sine 60. So this is point C. So velocity speed C will be 2R sine 60 into omega, which is R omega root 3. Easy? Speed वही करना था. That's why I asked you speed. You want I cap J cap तो वो करना पड़ेगा, वो circular motion, transition, rotation करके. How many points on the disk with speed V? That's a good one. V is the speed of the center. Third question, find the radius of curvature of the topmost point and the horizontal point. Any doubts on this? Please ask me. The speed part. This will be a very good technique. We will see later on EMI chapter. Get that second to everyone. Show you? You got it right. Why? मुझे देखो कैसे. There are infinite points. देखो. If you take the disk, this is your IIR. So from IIR, if we take a circle of radius R, all the points on the circle will have a speed R omega, isn't it? Isn't that the speed of formula? The distance from the IIR into omega. That means all the points on the disk will have a speed of R omega, where R omega is nothing but V. Make sense? All points at a distance of R from the IIR will have speed V. So there are infinite points. If it was a ring, there'll be 2 points. Disk, right? There are multiple points. Sure, everyone? If you try to do this normally, क्या होगा पता है? देखो, if you try to do normally, you take a point here at an angle theta. This will be V here. This will be R omega theta. This will be root over V square plus R omega whole square plus 2V R omega sine theta cos theta. ये होगा sine theta actually. Sine theta. This is the speed of the particle. This should be equal to V. So you get r square omega square plus 2v r omega sine theta is equal to 0. For different values of r and theta, you can satisfy this condition. There'll be infinite points. But wo click nahi hoga when you see this equation. Because see, you can change the distance, you can change the angle, na? So you can find infinite points on the disk whose velocity will be v. That is a little difficult to see from that equation, but IRs, it looks so easy. If I ask you how many points are there on the disk with speed root 3v, same logic, na? Root 3v, draw a circle, infinity. Make sense? How many points with the speed 2v? एक ही point होगा. Highest point, बस हो गया. That way you can play around. Question अभी तक हुआ नहीं. Find radius of curvature of A and B. That's a good one. Again, be careful. IAR has nothing to do with radius of curvature. दोनों का कुछ relation नहीं है. Most people get confused. They say like, sir, but you only told the body is rotating about point A. मैंने क्या बोला? Body is rotating about point A. The body is in pure rotation about point A. So do you mean to say rotation and circular motion are same? Remember, this is something which we discussed in the beginning. Rotation alag hai, circular motion alag hai. Radius of curvature is defined for a path. IAR is defined for a body. How to find radius of curvature? If you remember, A centripetal is V tangential square by R. So radius of curvature will be V tangential square by A. Right, Anusha. Try. I give a minute. Lakshika got it. That is your first answer today, I guess. Anusha, I got that. Ouch. So if you take the highest point, this velocity is 2v. This is your centripetal acceleration, which is omega square r. So radius of curvature of A will be velocity square by acceleration perpendicular. So here it is perpendicular only. So 4r square omega square by omega square, you get 4r. Be careful. IR ka distance 2r tha. IR ka distance is 2r, but that is not the radius of curvature. If you take this guy, this is nice. This speed will be v root 2. Now be careful here. This acceleration is omega square r. You never resolve velocity into components. Velocity को ऐसा ही रखो. Divide acceleration into components. This will be omega square r root 2. This is your A perpendicular. This is omega square r root 2. This is A tangential. So radius of curvature of B will be b root 2 whole square by omega square r root 2. This comes out to be 2 root r. Easy to remember, na? IR से जो distance उसका double आएगा. You can remember that way. It is easy to remember, but that's a wrong logic though. IAR has nothing to do with radius of curvature. Luckily, it works out here. And remember, whenever we found radius of curvature, we always keep the velocity as it is. We divide the acceleration into components. Don't divide the velocity into parts. This is a net acceleration. उसका दो component होगा, tangential and centripetal. Just to give an idea, I'll turn the page. What is happening? This is lagging nowadays. Seriously, I think I need to keep this offline option. अरे गॉड कितना बफर हो गया है. We'll count 10 numbers. If it doesn't happen, then we'll write it later. 1, 23, 76, 103. I said 10 numbers. When did I say 1 to 10? E power minus 0.2. Ln 2.3. This is nonsense. It's not working. See? You have to just shout on it. It'll work. Remember this thing? Kinematics में किया था. The
Yeah.
path of a particle. Cycloid था ये. This path is called a cycloid. So when this path is going on a circle, at this point here, this is your IAR. But whereas the radius of curvature, right? This is the radius of curvature. Isn't this? This is how the path will go. It's a cycloid. किसी को याद है length कितना था? No one remembers the result? 8r. Distance traveled by the particle is 8r. Whereas this length is 2 pi r. Check कर लेना. We did this integration there. The radius of that thing is distance traveled is 2 pi. Displacement is 2 pi r, whereas the radius is 8r. So this is what is happening. The radius of curvature is different and IR is different. So we can write a statement there. IAR is defined for a body. Radius of curvature is defined for the path. They have no relation as such. Directly, कुछ भी relation नहीं है. So be careful. Don't mix it up and people write it. IAR का answers for radius of curvature. Clear with this? Have a look at this. Next thing. So how to look at this IAR? Turn in the page. Case 1. Consider any 2 points on the body and draw a perpendicular to the velocity. The point of intersection is the IAR. How does that work? Tell me one thing. What did you say? When you stand on IAR, you think every body is going in a circle? So if you take any body there, if you stand on IAR, you think this guy B is going in this circle. You think this guy C is going in another circle. Dono concentric circles tha. So for this C, if you drop in perpendicular, isn't it a normal passing through center? And for this circle, if you drop a perpendicular, isn't it a normal passing through this center? And for concentric circle, shouldn't the normals always pass through the center? Logic समझ में आ रहा है? The reason why this works is because about IIR, everyone is going in a concentric circle. For concentric circles, if you draw normals, they will always meet at the center. Make sense? So that is the reason this thing works. So you have any random body there. So if this is point A, let's say this is going with VA. This guy is point B, which is going like this with VB. So drop a line perpendicular to this and drop a line perpendicular to this. And the point of intersection will be IIR. If I give you one more example, this is our standard problem if you remember. The rod sliding on the wall. If you look at here, this point A is sliding this way. This point is sliding this way. So if you drop a normal perpendicular to this, and if you drop a perpendicular to this is your IAR. You can directly, find moment of inertia about that point and you find the kinetic energy of the rod. Just to show you how fast this will go, देखो ये theta होगा. So if this is your IAR, this distance is L sine theta. So what is omega here? Omega will be, if I take the speed as V, the tangential velocity v by L sine theta. You can find omega directly. You know how we found omega for this? Circular motion mein when we did this, देखो same question था, उसको में देखो कैसा calculate किया हमने. We found cos theta as x by L, then we differentiated and we found u by L sine theta. Or we said this method. This is how we found omega of the rod in circular motion. Look at here how we found here. एक step में आ जाएगा. This is IAR, so this is the circle here. Radius is L sine theta and velocity is v. So omega is v by L sine theta. Is this making sense? And what will be the kinetic energy of the rod then? Kinetic energy of the rod will be half. Find moment of inertia about IAR into omega square. Can someone tell me IAR कितना होगा? Get this. Find the kinetic energy of the rod now. Find the moment of inertia about that axis. Length, mass is m and length L. Find the IAR of that rod, moment of inertia of the rod about the IAR. Length of the rod is L, angle theta, mass m. A ka speed is v, given. This is how they'll ask a question. Find the kinetic energy of the rod. This does not work in any formula that we know. Because this center of mass itself is going in a pretty weird path, circular path. तो बहुत difficult होगा इसका. Velocity center of mass निकालो, then calculate. Quite complex, but IR will make your life very easy. Find the moment of inertia about IAR. Try, I'll give you a minute. I hope now you're understanding how important that moment of inertia was. b by 6 sin theta square होगा. देखो IAR कैसा करेंगे? This is 0, 0. This is L cos theta, 0. This is 0, L sin theta. So center of mass का coordinates will be L by 2 cos theta plus L by 2 sin theta. This is your IAR. जिसका coordinates होगा L cos theta, L sin theta. So this distance is d. So d will be L by 2. Calculate करके देखो distance formula. So I about IAR is parallax's theorem. Which should be ml square by 12 plus ml square by 4, which is ml square by 3. That's your moment of inertia. अभी वो यहाँ पे डाल देना. This will be half ml square by 3. Omega square will be v square by L square sine square theta. So the kinetic energy of the rod will be mv square by 6 sine square theta. It does depend on theta. Check करना क्या क्या. I found the coordinates of center of mass and IR and I found the distance between them. Then I used parallax theorem. Moment of inertia is not depending on theta here. Cancel हो रहा है theta square करेंगे तो distance. Once you got that, you're done. You're getting how useful this is? If you try to do that kinetic energy of the rod normally, you won't be able to do this. Because I don't know the center of mass का velocity I have to find. That is a big mess. Omega find करना है. Have a look at this. Let me give you one more like this. So using this as a base, can you try this? Same question, but this time I'll give like this. ये होगा 120 degrees. thin rod, mass m, length L. This is 30 degrees and this point A is going with U. Find kinetic energy of the rod. Try. I just change the perpendicular से angle बना दिया मैंने. Find the kinetic energy of the rod. And why we calculate moment. So what is kinetic energy का formula, God? Half moment of inertia about IR omega square. ना you're saying rotation about this point. तो half I hinge omega square, right? तो hinge का moment of inertia निकालना है ना. That's why. I hope everyone got this thing. Try this. It's a good one. You get a pretty interesting answer. Find kinetic energy of the rod at this instant. It keeps changing, but at this instant. Any answers? 5 mv square by 6. और किसी को आया? Hmm, 5 mv square by 6. We have two answers with 6. Okay, we have 3 people with the same. So maybe right. देखते हैं. Step 1, find IAR. So उसके लिए पहले find 2 points whose velocity का direction you know. Velocity का जरूरत नहीं है. I want direction. So this is one point here. Drop the perpendicular and drop the perpendicular. So this should be your IAR. If this is 30, this is 60. This is also 30, so this is also 60. It is actually an equilateral triangle. OAB is an equilateral triangle. This makes you half your life easy. Let's call this point O. This is your center of mass. तो ये distance होगा √3 L by 2. Omega कितना होगा? Omega तो directly this distance only ना. This is L. So omega is directly U by L. Moment of inertia about IIR, parallax theorem, ml square by 12 plus m √3 L by 2 का whole square. That is a height. ml square by 12 and 3 ml square by 4. ये होगा 5 ml square by 6. Kinetic energy of the rod will be half IAR omega square half 5 ml square by 6 v square by L square 5 mv square by 12. How did you guys get 6? क्या goof up किया आप लोग? 3 people got the same 6, 6, 6. Where did you mess up? What did you guys take? कुछ तो किया, सब लोग वही mistake किया. or all are sitting in the same room and copying. आप भूल गया. Okay, आप भूल गया. Okay, you forgot आप. What about others? अरे Abhinav, what did you forget?
The same.
आप भूल गया. अरे काइनेटिक एनर्जी आप एम स्क्वायर कैसे भूल जाएंगे रे? ठीक है, देख लेना. गॉड्स ऑलर आप कैसा भूल गए रे? V square L by 2. Anika, I didn't get what you're asking. वो क्या था? What is V square L by 2 square? What is that?
For the omega, wouldn't
Omega is
radius
what? V tangential by radius ना? तो ये सेंटर था, ये रेडियस था और V tangential था.
Oh, okay.
बस हो गया ना, कुछ करने की जरूरत नहीं था यहाँ पे. Just straightforward. Got this, everyone? It's a good one. It's not tough, but if I ask you kinetic energy rod, there is no other way to do this normally. It becomes very complex if you try to do any other method. IR saves the thing here. Clear? Can I turn the page? If I give one more example, let's say we have a block A here. It is fixed between two walls. So A can move only left and right. Someone connected this to a rod. So this is hinged here. This is another hinge here. This is another hinge here. Let's call this B. Okay, this is a hinge. Diagram समझ में आ रहा है कैसा है? So when this rod rotates, it will push this thing, so A will go this way. So can you find IAR of the rod AB? Find IAR of rod AB. Now see, ये rod जो है, that is not going properly because B itself is going in a circle and top of it, this rod is also bending. So B is like a supporting hinge, which can movable hinge. This is fixed to the ground. And the hinge to A can only make it go left and right. Just IR का location चाहिए. See, what did I say for IAR? Find 2 points whose velocity you know. How is A going? Straight. How will B go? B will go in this circle, na? Because A length constant tha. So B will go perpendicular to this length here. Make sense? So now drop a perpendicular to this line and drop a perpendicular to this line. This would be IAR. Make sense? Find the velocity of B, uska perpendicular, and find the velocity of A, uska perpendicular. The point of intersection is the IAR. This is a line perpendicular to VB. I didn't draw the diagram properly, but yeah. No, if you just forget about this rod now, isn't that how it is going? This is the hinge. Because the length of the rod is constant, the B has to go in a circle. So A is going in a line and B is going in a circle. So we have 2 points, one is going in a circle and one is going in a line, and unka bhi IR hoga. So there I can give you some weird shapes and ask you IIR also, but okay. I can ask you find kinetic energy of that rod now. Same logic. Find moment of inertia, find omega and finish it off. Clear how to look at IIR now? Clear everyone? Next thing. Maybe na thoda diagram I should have drawn little low, that would have been better, I guess. This would have been better. This would be your IIR. Make sense? Kinetic energy will be 5 mb square by 12. Which question you're talking? This question. Equilateral triangle नहीं बनेगा God. इसमें 5 mb square because equilateral triangle था वो. हर बार 5 mb square by 12 क्यों आएगा? Right? Now, other than this, there are two more cases. These are easy. What if the two particles' velocity v1, v2 both are parallel? Now, what is the problem? If you drop a perpendicular, there's only one line. That means IIR should be somewhere on this line. So this is the logic we use. Let the distance be d between them, and let this distance be x. Since IIR, omega should be same. v1 by d plus x should be equal to v2 by x. From here, you can calculate x ka value. If the velocities are parallel, then you're stuck. Then there's only one line. There is no intersection. But then you can use this logic that omega is same. If they're not parallel, then it's a point of intersection. Case 3, what if they're anti-parallel? Again, same logic. So in this case, IAR will be somewhere in the center. Let this be x and let this be d minus x. Omega will be v1 by x, v2 by d minus x. And that's how you can find x here. So if you're parallel and anti-parallel, this is a method. If you're not parallel, then it is fine. Check it out. Clear with this, everyone? That is about IIR. IIR is especially useful when you talk about energies. Clear? Can I go ahead? Next thing, angular momentum. We will do a little introduction. Next class, we'll continue with this. Angular momentum is completely different game. Till now, what you did is one, and that is a different monster. Generally, angular momentum, right? At our level, it is still okay, but people at MSc level, people say like it is even more complicated than quantum mechanics. You will see some cases like, problem kya na angular momentum. It is difficult to visualize what the hell is happening. Mathematically, it makes sense, but physically, it doesn't make sense at all. We will see. But don't worry, at least 11th and 12th, it's complex. The major problem that I see, right? People find angular momentum complex because, first of all, they don't know how to calculate. So we will first work on calculation, then we'll go for conservation. So we will just do introduction today. Angular momentum, symbol is L bar. So again, for angular momentum, we have two things, a particle and a rigid body. So for a particle, the formula is given by L bar is M, R bar cross V bar. This can be written as R bar cross P bar, where P bar is momentum. R bar is a vector from axis to the particle. Just like torque mein r cross f bar, r bar is a vector from the axis to the force. P bar is your linear momentum. So if you have velocity here, if this is your r bar and this is your axis, this is angle theta, you can write this component as v cos theta. Same thing we did in torque also. V sine theta, this will become v perpendicular. So we can write angular momentum m r v sine theta as m r v perpendicular. Same thing we did in torque, remember rf perpendicular. So you can find angular momentum using m r v perpendicular, or if this is v bar, extend the vector theta, from here drop the perpendicular, r perpendicular will be r sine theta. It has a lot of similarities with the torque thing. So we can write here, so if you give that sine theta to r, we can write this as m r perpendicular v. This is how you get the magnitude for an angular momentum for a particle. You can find angular mrv perpendicular or mr perpendicular v. Both are same. Have a look at this. This gives you the magnitude. Clear? Have a look at this. It has quite resemblance with the torque. R perpendicular F and RF perpendicular. Direction का logic भी same है. We use right hand rule. Assume the direction of the R bar rotation and then we use K rotation, right hand thumb rule. The direction assume R bar is a rod rotating. And use right hand thumb rule. The same way we found direction for torque. So if this is your velocity, if this is your R bar and this is your axis, think of like this. R bar is a rod. So for this rod, if you pull this way, how will it go? Right or left? It will go to the right side. Means it is a clockwise rotation. So plus K cap, minus K cap. If this is your V, this is your axis. This is your R bar. Same thing here. This rod would have rotated this way. So this is a plus K cap rotation. Check. That's how you find the magnitude and the direction. Clear? Let's see a question. Mass of move 2 kgs, moves with velocity v bar 3i 4j minus 5k at 1 comma 2 comma 3. Find angular momentum about minus 2 comma 1 comma minus 1. So matlab minus 2 1 comma minus 1 is the axis. The particle is at this point and this is the velocity. Find angular momentum. Direct formula substitution. 18I24J minus 30K. Okay. Yeah, one answer. So this is V bar. This is 1, 2, 3. Axis is somewhere here, -2, 1, -1. This is your R bar. That is final minus initial. The 1 minus -2, 3I cap. 2 minus 1 J cap. 3 minus or minus 4K cap. Please check whether you got the R bar right. Then you do R cross V bar. Mass end में multiply करते. Then 3 into 3 det. This guy R bar na first 3, 1, 4, 3, 4, -5. So this would be I into -5, -5, -16, -21. Am I right? Did I goof up somewhere? Okay. -J, -15, -12, -27, 12 minus 3, 9. L bar is MR cross V bar, -42 I cap, 54 J cap, plus 18 K cap. Check, did I mess up anywhere? Direct formula substitution, there's nothing there. Just have to be careful with each one. Check my calculations. Clear with this? There. So when we catch up on Friday, we'll continue from here. So we are going to do more calculations of how to find angular momentum of a rolling body, rotating body, all that stuff. And then we will do conservation basic problems. I think next week, Wednesday, we'll wrap up the chapter though. So angular momentum have pretty good ones. I think we will touch almost 65, 70 problems. We already did 55. So first make sure to revise, go through them. And I sent you a sheet on more than one choice questions also. You can go through that. Okay, with that we'll wrap up for the day. So on Friday we'll catch up as usual at 5:30. All right. So any doubts, anything, please stay back or else you're free to leave and make sure